Section 3.1, example 6, evaluating functions at specific values. Evaluate f of x equaling x squared plus 3x minus 4 at each of these values. So let's start with the very first one. Let's start with 2. Move this to give us a little bit more room. So we have the function f of x. F of x is equal to x squared plus 3x minus 4. And we want to evaluate it at 2. So everywhere we see an x, we're going to replace it with 2. So f of 2 is equal to our input squared plus 3 times our input minus 4. Everywhere we see an x, we're going to replace it with 2. And let's simplify. 2 squared is 4. 3 times 2 is 6. Then minus 4. Here it's just equal to 6. This relation here told us that with an input of 2, we have an output of 6. Similar to the previous chapter, we have our xy coordinate and, or in this case, we could say x and f of x, input and output. Let's see the next part. Here we're replacing we're replacing x with a. So f of x is equal to x squared plus 3x minus 4. But instead of x, we're replacing it with a. Everywhere we see an input, we're replacing it with a, and there we go. Simplify it, we have a squared plus 3 times a minus 4. Next, we're going to do a plus h. Everywhere we see an x, we're going to input a plus h. So here we have the function f of x equal to x squared plus 3 times x and minus 4. Everywhere we see an x, we're going to replace it with a plus h. And here, tiny misconception. We have the binomial, bi as in 2 terms, binomial squared. So what we have to do is multiply these two, a plus h times a plus h. So the same thing multiplied to itself. Here we're distributing this 3 to these 2 terms. So 3a plus 3h minus 4. Let's expand this part. A squared plus ah plus ah plus h squared plus 3a plus 3h minus 4. And there was only one more thing that we could simplify here, and it's adding those two together. Everything else is individually there. So a squared plus 2ah plus h squared plus 3a plus 3h minus 4. And that's it. That's your solution there. Lastly, they want us to evaluate f of a plus h minus f of a, and all of that divided by h. All right, let's see what we have. F of a plus h. I'm going to put these in brackets just to kind of show a little bit of separation here. F of a plus h is what we just found right here. A squared plus 2ah plus h squared plus 3a plus 3h minus 4. We're subtracting f of a. F of a is a squared plus 3a minus 4. A squared plus 3a minus 4. And we're dividing all of that by h. This looks pretty terrible, so hopefully things simplify. So looking at these first set of brackets, it looks like we could just drop those because we don't have anything being multiplied out here in the front. But for this set of brackets, we have to distribute this negative through each of those 3 terms. So let's rewrite that first left part. A squared plus 2ah plus h squared plus 3a plus 3h minus 4. And distribute negative times a squared is a negative a squared. Negative times 3a, negative 3a. And lastly, negative times negative 4 is going to be a positive 4. Dividing all of that by h. And it looks like things started subtracting out. A squared, negative a squared. Positive 3a, negative 3a, negative 4, positive 4. So we're left with, oh no, we're running out of space. Let's bring this up here. We are left with 2ah plus h squared plus 3h. And it looks like that's it, ah. So we have 1, 2, 3 terms. 1, 2, 3. All of that divided by h. And it looks like everything has an h in it, so we could either factor it out or just divide each of them by h. I kind of like the factoring out just to strengthen our skills in factoring. Each of these have an h in common, and it looks like that's the most they have in common. So let's factor out a h for the numerator. H times 2ah divided by h is 2a. H squared divided by h is just h. And lastly, 3h divided by h is just 3. More importantly, we have a h in the denominator, so these two divide out perfectly. And we're just left with 2a plus h plus 3. And that's our solution for this last part. Oh, not that part, down here. So evaluating f of a plus h minus f of a all divided by h. That's our solution. If you have any questions, please feel free to ask. Otherwise, bye.